This is question 5 on the June 13 Stats 1 paper from AQA. So we've got a probability question. Alison's a member of a 10-pin bowling club. It meets on the bowling alley on Wednesday and Thursday evenings. So the probability that she bowls on a Wednesday and Thursday are independent events, so they don't affect each other. And the probability she bowls on a Wednesday is 0.9, probability she bowls on a Thursday is 0.95. So we can write this using some probability notation to start with. So probability that Alison bowls on a Wednesday, 0.9. Probability Alison bowls on a Thursday, 0.95. So the first thing I can think about is what's the probability that she doesn't bowl on a Wednesday. So AW dashed, what's 1 minus 0.9, 0.1. Probability that she doesn't bowl on a Thursday, AT dashed, is just 1 minus 0.95, so 0.05. So I can already work those out, they might come in handy later. Calculate the probability that during a particular week she bowls on 2 evenings. So she's going to bowl on the first evening, and she's going to bowl on the second evening, so I need to multiply those two probabilities together. And I should come up with 0.855. Probability she bowls on exactly 1 evening. So there's 2 options. She could bowl on a Wednesday and not on a Thursday. Or, so I need to add on, she could bowl on a Thursday but not on a Wednesday. So that's going to be 0.14. Part B. So we've got David, a member of the same club. So the probability that he bowls on a Wednesday is dependent on if Alison's bowled. So we're saying the probability that he bowls on a Wednesday, given that Alison bowls, so probability David bowls on a Wednesday, given that Alison bowls on the same day, that's going to be equal to 0.8. And probability that he bowls on a Wednesday, given that Alison does not bowl on a Wednesday, so Alison does not bowl, is 0.15. And then we've got a similar thing for Thursday, so probability David bowls on the Thursday, given that Alison's bowling on the Thursday, it's telling us that's 1. So whenever Alison bowls on a Thursday, David also bowls. So probability that David bowls, given that Alison doesn't bowl, well, if she hasn't bowled, then he isn't going to bowl either. So that's a probability of 0 there. Okay. So I've written those down. So the probability that Alison and David bowl on a Wednesday. So the probability of Alison bowling, 0.9. And the probability that David bowls, given that Alison has bowled, is 0.8. So I need to multiply those together. So 0.72 is my answer there. Part 2, Alison and David bowl on both evenings. So we've got them both bowling on the Wednesday, 0.72. And now we need to know what's the probability of them both bowling on the Thursday. So we need to multiply that by the probability that Alison's bowling on the Thursday, 0.95. And if Alison bowls, then we've said that David is definitely going to bowl. So we times that by 1. So my answer for that part is 0.684. That's 2 marks for that. Part 3, Alison, but not David, bowls on a Thursday. So the probability that Alison's bowling on a Thursday is 0.95. What's the probability that David doesn't bowl on a Thursday, given that Alison does? So we need to come over here. So David bowling on a Thursday, given that Alison bowls, is 1. The probability David doesn't bowl on a Thursday, given that Alison bowls, is going to be 0. So if we try to answer that question, we're going to do 0.95 multiplied by 0. So the probability is 0. So if Alison's bowling on a Thursday, David would definitely bowl. And then the fourth part there, neither of them bowls on either evening. So probability that Alison doesn't bowl on a Wednesday is 0.1. Probability that Alison doesn't bowl on a Thursday is 0.05. And then we also have the probability of David not bowling. So David not bowling on a Thursday, given that Alison hasn't bowled. Sorry, on a Wednesday, if we start with Wednesday. So on this one here, we're saying that David bowls on a Wednesday, given that Alison didn't bowl. So if we want the probability David doesn't bowl on a Wednesday, given that Alison didn't bowl, we need to do 1 take away 0.15. So that'd be 0.85. And we also don't want David to bowl on a Thursday. So the probability of David not bowling on Thursday, given that Alison didn't bowl on a Thursday, well, the probability that he does bowl, given that she doesn't, is 0. So the probability that he doesn't bowl, given that she doesn't, must be 1. Because the probabilities have to multiply to 1. So I've got 0.1 times 0.05 times 0.85 times 1. So that all multiplies to 0.00425.